Morning, folks. This will be a 2 to 3 part series on how to accomplish the TLL load charts. This first section is just going to be talking about the fundamentals of TLL and what you need to remember and read in the TLL load chart book. Part 1, we're going to cover the core factors: mastering the radius, angles, and ground conditions. Radius and deflection. As we increase radius, which is the horizontal distance from the center of rotation to the crane to the center of load or center of the load line, or the center of gravity of the load. Small radius changes will cause huge differences in capacity. And as we reduce radius, we increase our capacities. Radius inherently increases when the boom deflects under load, or if the load swings out dramatically. Things like you're not over the top of the center of gravity of the load. You're swinging too fast, the load will kick out. You're going from a high spot to a low spot in your terrain. Never estimate the radius. Always verify and measure prior to initiating a lift. If your radius indication is wrong, you need to pull tape. Get out of the cab and pull tape. All right, here are the fundamental rules that you have to follow for TLL. All cranes have their own specific rules. When the measurement or the radius is between listed values, always use the rating for the next longer radius. To ensure a conservative capacity, we always err towards the worst case scenario. Unlisted lengths. For boom lengths not listed, use rating for next longer boom length or next shorter boom length. We call those the 2-finger rule. We go down both columns. Again, that is to give us the worst case scenario, which gives us the smaller capacities. Unlisted angle. When calculating fly capacities for angles, not just fly, for calculating boom angles, when the angles are not shown, we get to the next lower radius. We always err towards lower capacity. And remember, as we lower boom angle, we're shifting the load farther out, which is going to decrease our capacities. Always go to the next lower allowable boom angle. We also call that the loaded boom angle. This crane is set up based on a 1 degree of level. Those capacity charts are not valid unless you're at a 1 degree of level. The crane must be leveled on a firm supporting surface. If the ground is poor, your load charts are poor. And you must add cribbing or structural support under the outrigger pontoons, or also the pads. Remember, the pads shall be pinned to the cylinders. You shall have cribbing that is supporting both the weight of the load and the weight of the crane on those corners. Remember, corners are the greatest point of ground-bearing pressure. Pinned fully. Pad pinned. No cribbing under the beams. When operating on outriggers, all tires must be free of supporting surface before lifting. If the crane is not on all, off the ground, all four evenly, you are now unstable. You're potentially on the on-rubber chart. If you're unstable, your crane is going to tip. You have to have the tires up off. Think of it like this. When you have a sidewall of a tire, you're going to rock and lean a little bit more instead of when you're on your outriggers. Capacity limits. Understand that bold line, total loads, and deductions. So, when you look at your TLL load charts, you will notice that there is a bold black line or shaded areas. The shaded areas represent the capacities above the bold line on load charts represent structural stability, structural integrity. Those limits are based purely on the physical strength of the crane's components, hydraulic limits or rope strength, and not on overturning forces. We always base it on structural stability. How capable is your boom to support the load? Now, when we install the jib on the boom tip, we have to remember that jib charts are based on structural stability. If your boom is not structurally sound, you will have a catastrophic boom failure, a potentially dynamic unloading of the load, and killing somebody. Stability, anything below the black line. We also call that black line the tipping fulcrum. It's represented by capacities below the bold line. These are based on the crane's center of gravity. Ratings on fully extended outriggers do not exceed 85% of the tipping loads. If you're on rubber, it's 75% of your allowable line pull. And if you're on crawlers, it's 75% of your allowable line pull. Oh, when we talk about total load, we're not just talking about the crane picking up an actual load off the ground. Where the crane is loaded by the total load, not just the object. Rated lifting capacities include the weight of the hook block, slings, buckets, magnets, auxiliary lifting devices, the jib, if it's installed and you're not lifting off of it, and excessive parts of wire rope. Don't forget, the auxiliary line, the whip line, may also be deducted if it's installed at the jib tip or boom tip on the auxiliary boom head. All of that must be deducted. If extra wire rope is reeved beyond the minimum required, operator must deduct 1 pound for each extra foot. Not negotiable. The TLL load charts deduct for excessive rope. Don't forget this. Dynamic swinging. Control your load. The rated capacity is strictly based on the freely suspended load, 1 degree of level, with no external horizontal forces applied. To prevent dangerous dynamic swinger or pendulum action during rotation or transit, a tag line or a straight line must be utilized. Control your load. Start slow, end slow. Prevent dynamic loading and dynamic unloading if something catastrophic happens. As we swing faster, the load will kick out due to centrifugal force. Spin a yo-yo in the air, it will swing out. The faster you go on the inside circle, the faster it goes on the outside circle. You will tip if you go from a high capacity, or potentially tip if you go from a high capacity quadrant to a low capacity quadrant. Remember, the front of the TLL crane is the strongest quadrant. But if you cross over into the side, you better be on the 360 chart and not still on the on front chart, or you could potentially tip over because you're not using the configuration of the crane properly. Strong quadrant to a weaker quadrant, always err towards the lower capacities. So you do not tip. You shall not, you must not exceed your rated capacities. You do not tip the crane to determine allowable loads. Do not exceed the maximum capacities. Here are my sources and references. You'll notice American Society of Mechanical Engineers, B30.5. You're also going to see the CCO load chart book, TLL. This completes the primer to the TLL load charts.